Welcome back to Geometry, Measurement, and Probability. In this video, we'll be looking at section 12.1, talking about congruence. So let's get started. Similar objects have the same shape, but not necessarily the same size. The symbol that we use for similar is a squiggly line called a tilde. Congruent objects have the same shape and the same size. Now notice the symbol that we use for congruent is an equal with the squiggly line over it. Congruent objects are always similar, but similar objects are not always congruent. Now, two line segments are congruent if their lengths are equal, and two angles are congruent if their measures are equal. Another topic in this section is constructions. There is a separate video that focuses on our geometric constructions. Be sure that you watch this video because you will have constructions as part of your homework for section 12.1. It will count as part of your quiz grade for this particular section. For constructions, you will need a compass and a straight edge. Now let's continue thinking about our congruence. Two figures are congruent if we can fit one figure on top of another so that the matching parts coincide. When we name congruent figures or congruent parts, we always name them in the order that they're congruent. So notice here that A and A prime are congruent, B and B prime, C and C prime. For triangles to be congruent, all of their angles have to be congruent, and the sides have to be congruent. We say this as CPCTC. Corresponding parts of congruent triangles are congruent. In example 1, we are asked to use the appropriate symbols to show the congruence for each of our pairs of triangles. Look at part A. So we have triangle ACB. Now the order that I named the first triangle does not matter. Our symbol for congruent is an equal with a squiggly line over it. As I begin to name the second triangle, my matching pieces need to be named in the same order. So I need to think about what piece of the second triangle matches A in the first. Well, that would be E. Then what piece matches C? C and D match, so the next letter would be D. And last, that leaves us with B and F matching. Look at part B. Again, the order that I name my first triangle doesn't matter. So I'm going to name this one triangle ABC. Don't forget your symbol for congruent. And then I'm going to start thinking about my second triangle. Again, our matching pieces need to be named in the same order. So I need to figure out which of my pieces match in my two triangles. Now remember, the sum of the measures of the angles of a triangle is 180. So in the first triangle, I have 60 degrees and 90 degrees, that's 150. I need 30 more degrees to make 180. A similar thing happens in the second triangle, but I would need 60 degrees to make 180 degrees in that triangle. Now I can see which pieces match. A and R match, B and Q match, and then C and P match. One way that we can tell that triangles are congruent is by side, side, side. So if three sides of one triangle are congruent to three sides of a second triangle, then our triangles are congruent. Look at example 2. We're going to use side, side, side to explain why our two triangles are congruent. So let's start thinking about our matching pieces. Line segment AB is congruent to line segment ED. Now notice that A and E match, and so I named those in the same order, and B and D match. Let's look at my next side. Side BC is congruent to side DF. Again, matching pieces are named in the same order. Notice the line segment symbol above my letters. And then last, side AC is congruent to side EF. So we have side, side, side. And then I name my triangle, so I have triangle ABC is congruent. Don't forget your triangle symbol for the second triangle. and matching pieces need to be named in the same order. A and E match, B and D match, and C and F match. We have what's called our triangle inequality. And what this says is I can add any two sides of a triangle, and that sum is going to be greater than whatever the length of that third side is. Here's how that works. In part A, we have 3, 4, 5. We want to know is, can these be the lengths of the sides of a triangle? So I'm going to start with one pair. So 3 plus 4 is 7, and 7 is greater than that third side, is greater than 5. So we have a check. So let's look at another pair. 4 plus 5 is 9, that's greater than 3, the other side. And then our last pair, 3 plus 5 is 8, is greater than 4. So these could be the lengths of a side of a triangle. Now look at part B. Let's start with our first pair, 2 plus 6, that's 8, it's greater than 3, so that's correct. Let's move to the next pair. 6 plus 3 is 9, that's greater than 2, so that's correct. And then our last pair, 2 plus 3, that's 5, that is not greater than 6. And so these could not be the lengths of the sides of a triangle. In our next video, we'll pick up with side angle side congruence.